future systems. Technology is often described in dramatic terms: breakthroughs, disruption, transformation. This channel takes a different approach. We look at what these systems actually do, how they're used today, and what follows from that in practice. In this episode, AI images, how they're created and why they can look convincing. Most people think AI-generated images are rare. In reality, they're already common. A product photo that never existed, a background in an advertisement that was never built, a person in a social media post who was never photographed. You usually don't notice because nothing looks unusual. Images have a special role in how we process information. We question text, we interpret speech. But images, we tend to accept them. That's what makes this category different from language systems. You're not reading a claim, you're seeing something that appears to have happened. And that changes how we react to it. AI doesn't draw a picture the way a human artist would. It starts with noise, random pixels, like static on an old TV. Then, step by step, the system removes uncertainty, not toward a memory, but toward a structure that feels plausible. Edges appear first, then shapes, then textures, then small details, reflections, shadows, the way fabric folds. At no point does the system know what the object is. It only narrows probabilities until the image becomes coherent. And here's the key thing to understand. An AI image is not a stored picture being retrieved. It's the most statistically plausible image that fits the description you gave it. That's a fundamentally different process than memory or photography. Human perception treats visual detail as evidence. Small imperfections signal authenticity, skin texture, lighting variation, depth of field. These details tell our brain that what we're seeing is real. AI systems learn these signals from millions of examples, so they reproduce the visual cues our brain naturally associates with reality. That's why a generated image can feel more believable than a written explanation. Not because it's true, but because it matches how real images usually behave. The realism doesn't come from the system remembering something. It comes from the system recognizing patterns in how real things tend to look. It's familiarity, not memory. Despite the realism, the system has no understanding of the scene it's creating. It can produce a hand, but it can't reliably count fingers. It can place objects in a room, but it doesn't reason about physics or gravity. It can generate environments, but it can't track a consistent history across multiple images. The errors happen where relationships matter. A reflection that doesn't match the object. A tool being held in a way that makes no sense. Text that almost reads correctly, but doesn't quite. These mistakes aren't random bugs that will be fixed soon. They reveal something fundamental: the absence of understanding. The system doesn't know what hands do, or how mirrors work, or what words mean. It only knows what these things tend to look like. Today, AI-generated images function as production tools, not finished products. Designers use them to explore ideas quickly. Marketers test concepts before a photo shoot exists. Educators illustrate abstract topics that are hard to photograph. In most cases, the image isn't the final output. It's a step in the thinking process. The value comes from speed of iteration. You can see possibilities before committing resources. You can test 5 different visual directions in an hour instead of a week. Used this way, the technology supports decisions rather than replacing them. The person using the tool still decides what works, what doesn't, and what needs to change. It helps to treat an AI-generated image as a visual suggestion, not a record of reality, not a memory, not documentation, but a plausible appearance generated from patterns the system has seen before. The system doesn't know what the scene means. It only knows what similar scenes tend to look like. So an AI image answers a different question than photography does. Photography asks, what was there? AI asks, what would it look like if it were there? That's a useful distinction, because once you understand that difference, you stop expecting the image to serve as evidence of something that happened. You start treating it as a visual hypothesis, something to evaluate, not something to assume. As images become easier to generate, the role of visual evidence changes. Seeing is no longer the same as witnessing. Verification shifts from perception to context. We rely less on appearance and more on source, consistency, and corroboration. This doesn't make images useless. It changes how we interpret them. A photograph used to carry a certain kind of authority. Now that authority needs to come from somewhere else, from who created it, why, and whether the context supports it. Understanding that shift helps you avoid both overtrust and overreaction. You don't need to assume every image is fake, but you do need to ask where it came from and what it's actually showing you. There are a few common ways people misinterpret AI-generated images. The first is assuming that if an image looks professional, it must be real. But visual polish doesn't indicate authenticity. It just indicates the system was trained on professional imagery. The second is treating minor errors as proof that something is fake, when in reality, real photographs also contain imperfections, compression artifacts, and odd lighting. The third is underestimating how quickly these systems are improving. An error that's common today might be rare 6 months from now. None of these mistakes are unreasonable. They're natural responses to a shifting baseline of what images can be. But recognizing these patterns helps you evaluate images more carefully without swinging between blind trust and total skepticism. In practical terms, this affects how images should be used in decisions. If you're relying on an image to verify something happened, you need more than the image itself. You need context, metadata, corroboration from other sources. If you're using an image to illustrate a concept or explore a possibility, the technology works well. The image doesn't need to be real, it just needs to be clear. The key distinction is between images as evidence and images as communication. Evidence requires verification. Communication requires clarity. When those two get confused, problems emerge. Not because the technology failed, but because it was used for the wrong purpose. Understanding that boundary makes the technology more useful, not less. This was an overview of how AI image systems work and how they should be interpreted. The goal of this channel isn't prediction, but understanding. To separate appearance from mechanism. In the next episode, we'll move from images to moving images, where motion introduces new possibilities and new ambiguities. Future systems.